Let us try to understand how we can calculate the concentration of unknown substance in an acid and base titration. Usually, we use the term molarity or normality to represent the concentrations. But here, I would like to represent the concentration in terms of moles per dm cube, that is in 1 liter. Mole is a fundamental unit for the measurement of any chemical entity. So to understand the amount of substance in moles in a titration, let us take one example. Let us take an example of a simple acid-base titration of nitric acid and sodium hydroxide. Suppose 20 centimeter cube of sodium hydroxide of the concentration 0.110 moles per dm cube reacts with 23 centimeter cube of nitric acid. We'll try to understand the amount of nitric acid used in this titration in terms of moles, and from that we'll try to understand the concentration of nitric acid. For this, let us first try to calculate the amount of moles of NaOH being used in this titration. From the problem itself, we know that the concentration of NaOH is 0.110 moles per dm cube. That is in 1 liter, or we can say it in 1000 centimeter cube. We can say 0.100 moles of NaOH are present in 1 dm cube of the solution. So let us try to understand how many moles are present in 20 centimeter cube. This is simple. We can understand that 0.100 moles of NaOH are present in 1000 centimeter cube. So how many number of moles shall be present in 20 centimeter cube? For this, we can put this as an equation as number of moles is equal to concentration multiplied by the volume divided by the 1000 centimeter cube. This is just a cross multiplication of this relation. And when we solve it, we get the answer 0.0022 moles. Now, just for the curiosity, can you tell me how many moles of NaOH remained in that 1 liter original 1 dm cube of the solution? It is simple to understand. We can remove 20 ml of this original solution, which was 1 liter, and the concentration was 0.110 moles. That means in that 1000 centimeter cube, there was 0.100 moles. So when we'll remove the 20 ml, it will have 0.0022 moles. So from the 0.110, we subtract 0.0022 moles, and we have some answer. It is 0.1078 moles in 980 centimeter cube. Now, for the further calculation, we need to understand the reaction. We understand that 1 mole of NaOH reacts with 1 mole of nitric acid to give 1 mole of sodium nitrate and 1 mole of water. So we know the concentration of NaOH used in this titration. From that, we have calculated the number of moles of NaOH, that is 0.0022 moles. Now, if 1 mole of NaOH reacts with 1 mole of nitric acid, then definitely 0.0022 moles will react with 0.0022 moles of nitric acid. So since you have done a titration, we understand that 23 centimeter cube of nitric acid was added from the burette, and 23 centimeter cube of nitric acid has 0.0022 moles. So when the solution of nitric acid, that is in 23 ml, there are 0.0022 moles, then in 1000 centimeter cube, we need to find out the amount of moles. So here also we can put the similar equation, it is just a cross multiplication of these two values, then we have number of moles of nitric acid is equal to concentration multiplied by volume divided by 1000 centimeter cube. That gives us the answer 0.0956 moles per dm cube. So the concentration of nitric acid being used in this titration is 0.0956 moles per dm cube. Just for the curiosity, may I ask you, instead of nitric acid, if we used to use H2SO4, what would have been the end point of this titration? Think about it. Thank you.